Hi students, in this video we will be looking at how we can write chemical formula for ionic and covalent compounds. So let's jump into question 1. Okay, so if we look at question 1, you can see that we are given the chemical name of some ionic compounds, the chemical formula using symbols, and we are asked to find out about two things here, right? Number one, the number of atoms present in these compounds, as well as the number of elements present. So these two types of questions are very, very common for chemical formula type of questions. So the way to look at it would be to, one tip is to really look at the number of capital letters that are in the chemical formula itself. Okay, to find out the number of atoms present. So for instance, if we look at the first example, 1A, magnesium chloride, okay, we see that over here there are two capital letters, right? So Mg and then Cl. Okay, so you notice that in the periodic table of elements, with every element, the first letter will always be a capital letter, right? Of course, for elements where the symbol only consists of one letter, then that letter itself would be a capital letter. For example, let's say oxygen and hydrogen. Okay, so I just wanted to use 1D to highlight a very common mistake. If you see calcium carbonate, right, the part that I circled, if you write capital C, capital O, this actually represents two different elements, carbon and oxygen, and CO is actually, big C, big O, is actually a chemical formula for a compound, carbon monoxide. Whereas if you write it as capital C, small o, okay, that would be an element, which is cobalt. So these two are vastly different. Yeah, so please take note of that. So now going back to the technique to doing this kind of question, using question 1 again, right? So if you look at magnesium chloride, you want to find out the number of atoms present, okay? You need to use the number, right? So for instance, you see Mg, there's no number there. When there's no number, it means it's 1. So technically it's Mg1Cl2. So if you want to find out the number of atoms present, it's simply 1 plus 2, which is 3. And then to find out the number of elements present, just as mentioned earlier, you will have to look at the number of capital letters, basically. So magnesium chloride, you can see that there's one big M, one big C. So that's 2 elements. Sodium hydroxide, 1, 2, and 3. Aluminum oxide, there's 2 capital letters. Calcium carbonate, there's 3. Lead-2 bromide, there's 2. Okay, so with these two little tricks, it should help you to tackle this kind of questions very easily. Okay, let's turn the page and look at part 2, which is on chemical formula for covalent substances. So there's some examples here for you. For instance, let's say sulfur dioxide, SO2, and example 2, which is dinitrogen monoxide, N2O. So for simple covalent substances, in terms of deriving the chemical formula, it's pretty straightforward. Mostly we look at the naming and more specifically the prefix. Okay, so if you look at the little table on the right hand side here, which I've done some annotations, right? Basically, the 3 prefixes that you should be familiar with, right, would be these 3. The first one would be mono. Whenever you see a mono, for example, carbon monoxide, right? Mono, that means 1. For instance, we say that, let's say there's a person who speaks in a very monotonous tone, right? Monotonous means, the person only speaks in one tone, right? In a very boring tone. Okay, so mono is a word that means 1. Di, on the other hand, you can look at the letter D and think of the word double. Double means 2. So whenever we see dioxide, right, that will be O2, made out of two oxygens. This is also a prefix that we have seen in the word diatomic, right, in our chemical bonding. Diatomic means made out of two atoms. Okay, and finally, you can think of the word triangle. So triangles are made out of three sides. So tri means three. Another common word would be polyatomic. Poly means many. Okay, so let's look at some questions in exercise 1. So part A, we have nitrogen dioxide. So nitrogen we know is N. So dioxide here, di means 2. So therefore, the chemical formula is NO2. Part B, sulfur is S. Tri means 3. So sulfur trioxide is SO3. Part C, disulfur monoxide. So disulfur means S2. Monoxide means one oxygen, right? So S2O. We do not write 1, so we leave it as that. Part D, carbon monoxide. So we have CO. Okay, so quite easy. Just take note this part at the bottom here. So even though we say that chemical formula for simple covalent substances, generally we can figure it out based on their naming. But there are 3 formulas of covalent substances that needs to be memorized in your syllabus. Okay, and these are compounds that we have seen many times already. So this is just a reminder. So first one we have water, which is H2O, ammonia, NH3, and finally methane, CH4. Okay, so this one you need to memorize. Let's turn to the next page and look at part 3, chemical formula of ionic compounds. So this part in general, we will make good use of our periodic table of the elements right there. Okay, to help us quickly determine what is the charge on our cation and anion. So as you can see for group 1 to 3, we know that these are the metals, right? They are on the left-hand side of the periodic table, and metals will tend to lose electrons to form cations. So for instance, if we look at our good friend sodium is 2.8.1. So it will tend to lose that one valence electron, and because electrons are negatively charged, it will form a cation and a plus with an electronic configuration of 2.8, which is the stable octet electronic configuration, right? So the same goes for group 2 and group 3, right? Subsequently, for example, magnesium, which is after sodium, it is 2.8.2. So now it will lose 2 electrons in order to form stable octet, hence Mg2+, and so on and so forth, so Al3+. Okay. Looking at the other side of the table, we have group 5, 6, and 7. These are the non-metals. And for non-metals, it is helpful if you look at it in reverse, backward. Okay, so you see for group 7, it's minus 1 minus, 2 minus, 3 minus. If we look at our good friend chlorine, 2.8.7, in the case of non-metals, it will want to gain 1 electron. In this case, for chlorine, to form chloride, Cl minus ion with a stable octet configuration of 2.8.8. Okay, so this is the general tip for you to make use of the group number of the element, which is basically placed in a certain trend in the periodic table, right? To help you quickly figure out what is the charge without having to go through the process of the electronic configuration and how many electrons lost. Okay, so this is like a quick way. So now let's look at example 1, sodium oxide, to demonstrate how to balance the charges so as to finally arrive at your chemical formula of ionic compound. Okay, so sodium, using the periodic table, we know that it's group 1, so it's going to form Na1+. Okay, so Na+. And then oxygen is group 6, so it will be 1 minus, 2 minus, right? So O2 minus. And So if you look at the cation and anion now side by side in terms of their charges, for every 1 unit of your cation at the moment, it gives you one positive charge. And then for every 1 unit of your anion, it gives you two negative charges, right? O2 minus. So one look, right? This little visual representation that I've drawn out, you can see that you can't balance the charges totally, right? So if I try to just draw it out, right, I cancel the one positive and one negative, I'm still left with a net negative. Okay, so using simple math and visually also I can see that in order to cancel out that final one negative charge, I still need one more unit of my cation. So meaning to say, this whole thing, I need to multiply by 2. I need to have 2 of it. Okay, 2 times of my cation so that I can nicely cancel out with the 2 negative charges. Okay, so in doing so, you can also again visually see and derive your chemical formula. So since I have 2 units of my Na, so it's Na2 with a subscript, Na2O. So that's the chemical formula of sodium oxide. Okay, so let's immediately apply this method to our questions in exercise 1. All right, so part A, we see calcium chloride. Okay, so calcium is in group 2, so it's Ca2 plus. Chloride is in group 7, so it's Cl minus. So again, we use that same method. For calcium, each unit gives me 2 positive charges. Chloride, each unit currently gives me 1 negative charge. So if I want to balance the charges for my ionic compound calcium chloride, I will need 2 times of my Cl minus, right? So that leaves me with the chemical formula of CaCl2. Part B, lithium sulfide. So lithium is group 1, so it's Li plus. Sulfur is from group 6, right? Just below oxygen. So going by the periodic trend, it's going to form S2 minus. Okay. So similarly now, you see cation gives me 1 positive charge, anion gives me 2 negative charges at the moment. So it's not balanced yet. I need to have 2 units of my cation. So times 2. So therefore, my chemical formula is Li2S. Part C, sodium nitrite. Sodium is Na plus. We know that by now. Nitrite, nitrogen is in group 5. So 1 minus, 2 minus, 3 minus. Nitrite is going to be N3 minus. So over here, obviously, it's not balanced. In order to balance out the 3 negative charges, I will need to have 3 times of my Na plus cation. So 3 times of that. And again, that will visually tell me that the chemical formula for sodium nitrite is Na3N. Finally, part D is a very famous question, aluminum oxide. So aluminum is group 3, so it's Al3 plus. Oxide, O2 minus. So over here, you can see that it's 3 plus and 2 negative charges, right? So for aluminum oxide, the best way to do it is to find the lowest common multiple, or in short LCM, of 2 and 3, which is 6, right? So for your cation, in order to get to 6 from 3, you need to multiply by 2. And for your oxide, you need to multiply by 3. So that gives you Al2O3 for aluminum oxide. Okay, let's turn the page to rule number 2. So yeah, so the idea of rule number 2 basically is just to remind you that if the charge of the ions is the same number, you should always reduce it to the number 1. For instance, let's say calcium oxide, you should write it as CaO and not Ca2O2. Likewise, for let's say example 2b here for aluminum nitrite, It is not Al3N3, but ALN. Okay, but just a huge disclaimer here for my students. As I mentioned to you, if you do the balancing of charges the way that I've taught you using my method, and not, let's say, the cross method, then this rule actually doesn't quite apply to you. And I'll demonstrate to you right now. Okay, so for example, if you look at the questions in exercise 2, part A, potassium fluoride, right? So we do our usual things using the periodic table to help us figure out very quickly what are the charges for the cation and anion. We realize that it's K plus S minus, right? So 1 unit of my cation gives me 1 positive charge, and then the anion gives me 1 negative charge. So over here, very quickly, we can see that it cancels out very nicely. So since it's 1 unit each of my cation and anion, so immediately I know that the chemical formula is Kf, right, for potassium fluoride. Likewise for B, magnesium is Mg2 plus, oxide is O2 minus. 2 plus, 2 minus, it cancels out perfectly, so it's MgO. Part C, calcium sulfide, Ca2 plus, S2 minus. Okay, you see the drill, right? So 2 plus, 2 minus cancels out perfectly, so it's 1 unit, 1 unit, so CaS. Likewise, part D, Na plus, Br minus for sodium bromide. Cancel, cancel, Na, Br. Let's turn a page to look at rule number 3. So here we're trying to find chemical formula involving transition metals. So the issue with transition metals is that they do not belong into any group. So that little trick that we were talking about just now doesn't hold true. But the good thing is for secondary school syllabus, for transition metals, most of them, they will give you in Roman numerals. So that will help you greatly. So let's say if we look at iron 2 chloride as the example. So iron is a transition metal, but they will always accompany it with a Roman numeral in brackets. So for instance, here is iron 2. So straight away I know it's Fe2 plus. Okay. So why plus, right? Because we know that iron is a metal and metals will form cations. Okay. So Fe2 plus. Yep. And for the chemical symbol, you can just get it from the periodic table lah. So that part is quite understandable. Let's look at the questions in exercise 3 to try a bit. So part A, copper 2 chloride. So copper is Cu. So copper 2 will just be Cu2 plus. Okay. Then again, we do that manipulation there. We notice that each unit of my cation now gives me 2 positive charges, while the anion only gives me 1. So to balance it out, I need 2 units of my chloride. So that one, whole thing I times 2. Therefore, leaving with my chemical formula CuCl2. Part B, copper 1, so it's Cu plus. Okay. To balance it out with oxide, I need 2 units of my Cu plus. So therefore, Cu2O. That's my chemical formula. Part C, iron 3 plus. We saw this a similar one earlier on. So if it's iron 3, then it's Fe3 plus. Okay, oxide is O2 minus. So over here, this is quite a similar example to aluminium oxide, where you see 3 and 2. So over here, we need to use the lowest common multiple, which is 6. So to get to 6 cation, we need to multiply by 2. And for the anion, we need to multiply by 3. So final chemical formula for for iron 3 oxide will be Fe2O3. Finally, part D, lead 2 chloride. So chemical symbol of lead is Pb. So if it's lead 2, then it's Pb2 plus together with chloride Cl minus. Okay, to balance it out, I need 2 units of my anion. So that leaves me with PbCl2. Okay, let's look at rule number 4, the last one. So over here, we're concerned about compounds with polyatomic anions. And we will definitely need to use a bracket if there is a subscript that follows it. So So for instance, I just use math to illustrate to you why the use of brackets in this case is very important, right? So for instance, if we look at the first one, 2 bracket xy versus if we don't use a bracket and I just have 2xy. These two are vastly different things, right? So for the first expression, I can expand out, multiply the coefficient 2 into the elements that are in the bracket, right, to get 2x, 2y. So that is very different from just plainly 2xy at the bottom. Okay, so we can see that in math as well as over here in chemical formula, the use of brackets uh, will mean very different things. Okay, so let's look at the exercises to see it in a more concrete way. Oh, but before that, let's talk about the table at the bottom. Okay, again, this one, please highlight that it needs to be memorized. All right, put a big star there. So, but let's run you through it. Okay, so for zinc and silver, these two are transition metal ions. All right, these are the two that you really need to commit to memory. That is part of the syllabus. The other transition metal ions, as mentioned previously, you don't have to memorize because they will give you the Roman numeral, so you will be able to figure out what's the charge immediately. Okay, but for zinc and silver, you need to remember that it forms Zn2 plus and Ag plus respectively. Next, let's look at ammonium. Ammonium is the only polyatomic cation that you need to memorize. So poly again means many. So this anion, or rather this cation, is made out of many atoms. Okay. Yeah, so that's NH4 plus, right? So this one I just want to again alert you, please do not confuse with ammonia. It sounds very similar, but they are vastly different particles. Okay, so ammonia is a covalent compound, a covalent molecule, whereas ammonium is an ion, a cation. Okay. Finally, the last four, these are polyatomic anions. Anions because they are all negatively charged, right? As you can see, nitrate NO3 minus, sulfate SO4 2 minus, carbonate CO3 2 minus, and hydroxide OH minus. Okay, so for these four, not to worry that it's too much to memorize because we will see this many times when subsequently we move to our next topic, which is acids and bases. Okay, and eventually on the topic of salts, we will see these all the time. Okay, so eventually you'll remember this by heart for sure. Okay, let's go through our final list of practice questions on the last page, exercise 4. And then this will very nicely wrap up our understanding of all the rules for deriving chemical formula for ionic compounds. Okay, so let's get into it. So part A, we have calcium nitrate. Calcium we know is a group 2 metal, so it's Ca2 plus. Nitrate, it is the one that we need to memorize, NO3 minus. So each unit of the cation gives us 2 positive charges, whereas nitrate only gives us 1. So if we want to balance, we know that we need 2 times of nitrate, right? So over here, it is Ca, and then taking note that nitrate is a polyatomic anion. So whenever it's polyatomic, we must be very careful to see whether the subscript is more than 1. In this case, it is, right? You need to multiply it by a factor of 2. So therefore, be very alert that you need to employ the use of brackets. Okay, so Ca, and then immediately open bracket NO3, close bracket 2. So that tells us that no, there's 2 times of my nitrate anion. And then for chemistry, chemical formula, the coefficient is expressed as a subscript. So the bottom number. Okay. Part B, iron 3. So it's Fe3 plus, and then sulfate is SO4 2 minus, polyatomic again. Right. So over here we see 3 and 2, right? So these two are the magical numbers, so we know that we need to arrive at the lowest common multiple, which is 6. So if you look at the cation, 3 plus, you need to multiply by 2 to get 6 plus. Whereas for your anion, you need to multiply by 3 to get 6 minus. So 6 plus, 6 minus, you cancel them out. Therefore, your final chemical formula is Fe2. Okay, and then again, taking note that sulfate is polyatomic. Remember to use your bracket. So bracket SO4, close bracket 3. So that is your formula for iron 3 sulfate. Okay. Part C, zinc carbonate. Zinc is Zn2 plus, carbonate is CO3 2 minus. Okay, so for this particular ionic compound, if you unfortunately cannot remember, right, you didn't really memorize the formula, and this comes out in exams, then it's going to be difficult because there's no way you can figure it out from the periodic table. Okay, so this is what we mean by you need to commit to memory lah. Okay, but otherwise, if you are able to write this down, then it becomes very easy because you see that there's 2 plus, 2 minus. In fact, this particular one, it cancels out really easily, very nicely. So that leaves us with ZnCO3 as the chemical formula for zinc carbonate. Then part D, copper 2 sulfate, Cu2 plus, SO4 2 minus. So yes, over here we have a polyatomic ion, SO4 2 minus, right? But you can see that it cancels out very nicely, 2 plus and 2 minus. So there's no need for a bracket here, okay? Because even if you put the bracket, right, bracket and then the coefficient is 1, you multiply in, it's still the same, right? So the answer is just CuSO4. Then moving down to part E, silver chloride. Okay, silver we must memorize, it's Ag plus, chloride is Cl minus, so here it's very neat, AgCl. Part F, sodium hydroxide, Na plus and OH minus. In fact, we'll see this a lot when we talk about bases and alkalis. Okay, so again, hydroxide is a polyatomic anion, but here it's not too much of a concern because it already balances out pretty nicely. So it's just simply NaOH. Part G, barium hydroxide. Barium is a group 2 metal, so it's Ba2 plus, OH minus. So 2 plus and 1 minus, you need 2 units of your hydroxide. So the whole thing times 2. So final chemical formula, Ba, open bracket, OH, and then 2. And last one is the most tricky, ammonium sulfate. Ammonium is NH4 plus, sulfate is SO4 2 minus. Okay, so draw out the charges. You have 1 plus and 2 minus. In order to balance the charges, you need 2 units of your cation, right? So over here you have 2 polyatomic ions, right? A polyatomic cation and a polyatomic anion. So over here you have to be extra alert, right? So if we do the balancing of charges, we realize that we are multiplying just the cation part by a coefficient of 2. So that is the component that we need to use brackets. Okay, so we'll start off immediately with a bracket, NH4 bracket 2, and then because sulfate is just 1 unit, right? So there's no need for brackets, we just copy it down. Okay, so that will be SO4. Okay, so yeah, that is it. We have completed worksheet 1, which is part 1 of our chapter, which is focusing on chemical formula. In the next video, we'll cover worksheet 2, which is on how we can write and balance chemical equations, including state symbols. Okay, so till then, let's call this a day, call this a night. 11:59 p.m. 1 minute to midnight. Okay, goodbye.